Hey everybody, Chili here. Let's take a look at the solution to coding challenge number 1, the pyramid challenge. But before we do that, we got to give mad props to our grand victor, Vit32. Give it up for Vit32. Also, we got our runners-up, Sirius3 and Final L, and a bunch of other honorable mentions. Congratulations for getting the correct answer, and thanks everyone for playing along at home. Alright, let's take a look at the pyramid puzzle here. What we're going to do is we're going to solve this with a bottom-up approach. Now, the way we're going to do this is we're going to consider for any given number here in the pyramid, what is the maximum expected value I can get from taking this number. So let's start at the bottom row then. What is the maximum expected value I can get from taking any one of these numbers? Well, since there are no numbers below them, the maximum value you're going to get is just these numbers. So here we've got our maximum values, and let's look at the next row now. So what is the maximum value for the second row? Well, it's just going to be the value of the number. So if you take 6, you're going to get 6 plus the value of the greater branch here. So if we take 6, we've got a choice of 1 or 2. So let's take 2 because that's the bigger one. And that means that our maximum expected value for this is going to be 8. Likewise, here it's going to be 5 plus 9 is 14, and here is going to be 9 plus 9 is 18. Again, for 6, it's 6 plus the maximum. And now look, we're looking at these values down here, the 8 and the 14, because that's what you're going to get in total if you take the 5 branch. So it's going to be 6 plus 14 is 20, and here it's going to be 3 plus 18 is 21. And then at the end, 2 plus 21 is 23. And there you go, you've got your answer. It's 23. If you wanted to reconstruct the path, you would just now do a greedy selection. So you'd go 23, 21, 18, 9, and here is your path. But for the competition, this is the only number that I wanted you to send me. Looking at the code, you're going to see it's pretty goddamn simple. I mean, here's the generate function I use to generate the pyramid. Use set W to get a nice alignment on those numbers there. Load pyramid is, we use getLine to load single lines. For every line, we put a new vector. We've got a vector of vectors of ints. So we put a new vector for every line. We use string stream to be able to get out single numbers out of that line. And there you go, and we return the vector of ints. And finally, solve pyramid is just what I showed you before. We take a vector of vectors of ints, that's our pyramid, and we start from the second row from the bottom, and we go to the top row. The reason we start from the second row from the bottom is because the bottom row is obviously already calculated. And we're just going to calculate those sums in place. So we're going to replace the values of those positions with their cumulative maximum path value. So we start from the second row from the bottom, and we go through each value in that row, and it is just going to be its own value plus the maximum of the one to the bottom left or the bottom right. So the bottom left has the same index, the bottom right has index plus 1. And that's it. Once you tabulate all the way up to the top, the very top is going to be the solution. So you just return pyramid.front returns the first vector, that's the first row, and then .front again returns the first element in that row, which is the solution. And then finally we call load pyramid with the name of the file, solve pyramid on the vector that it returns, and that will give us our solution, which should have been 31069. Definitely not a coincidence. I was asked how I got it to end in 69, and that's simple. I just ran a loop, it kept running generate, and then solving it until the solution had 69 in the final 2 digits. Brute force, but it worked fine. And that's it. Hope you enjoyed this little challenge here. These things, sometimes learning these new tricks and algorithms can be directly useful, can be applied to a program or game that you're making. Often, though, they can't, but they might teach an underlying concept that you can then generalize to a different problem. Like, for example, this algorithm here is a simple example of dynamic programming. So this will help you learn the technique of dynamic programming, which is very versatile. But I think the number one advantage to solving these problems and getting this practice in is it trains your brain to be able to just generally solve problems and develop simple algorithms. I'd say say probably the number one skill that a game programmer needs is a code architecture, software engineering skills. So stuff like being able to create abstractions, decouple things, create code cohesion, proper encapsulation, proper assignment of responsibilities, that sort of bullshit. But you still need to be able to develop algorithms. If you're making a shader, if you want to get a particular graphical effect, and you're like, I want this effect, how do I do it? If you don't have good algorithmic skills, you won't have the ability to connect the dots and to get the effect you want into code. So it's good to be well-rounded. It's good to get this kind of practice in there as well. So I'm going to be doing more of these challenges. Some will be more difficult, some will be less difficult. The next time I do this kind of challenge, I will probably go on my Twitter, on the forum, and I'll do a little announcement. I'll tell you guys when the challenge is going to pop so that you guys can be prepared and you can start getting at it right away. So keep an eye open on Twitter, on the Discord, on the forum if you want advance notice on the next challenge. Until then, thanks for watching, and I will see you soon with some more C++.